Hello everybody, in this lecture we will be going over 1988 IMO problem number 1. Here's a view of this problem. We are given two concentric circles with different radii, so let me go ahead and draw these two circles. So here is the first one and the second one. Probably let me just do a couple revisions here. Okay, and we are then told to pick a point on the smaller circle and fix it. So that's our point P, which is fixed, and have a variable point on the larger circle. So let's that point be B here, and we would like to connect these 2 points, and the intersection with the larger circle again is C, and then we draw a perpendicular from point P, and we hit the smaller circle again, which we call this point as A. First, this quantity here, the set of values that this quantity can take, and secondly, the locus of the midpoint AB. I believe this was the original problem. At first I solved it for BC, but anyhow, so the original problem I believe is AB. These circles are concentric circles, so that's the point O. I will reflect actually BC across O, and as a result, because of these 90-degree angles here, the reflection of BC across O would be a parallel line to BC, and I'll call these points as D and E here, and then I will get some rectangles. Well, obviously BDAP is a rectangle, as well as PAEC, or the bigger one as well. BDEC is also a rectangle. So these angles are all 90-degree angles. So let's begin with that quantity here, which let me just call it as, let's call it S, I guess. So S is equal to, so BC squared. BC squared, okay, so let's just, in fact, okay, so let me go ahead and make the following convention. So I'll call BP as U, U, and PC as V. So as a result, I have U plus V squared plus CA. Let's go ahead and draw these lines as well. So like that, and BA, as I would need it as well, would be like this. So CA, if you apply pi tag on triangle CPA, CA square would be just V square plus PA square plus, and AB is simply PA square plus PB square, but PB is just U, so but we already have a PA square, so 2 times PA square plus U squared. Okay, so we need PA squared, but because of these rectangles, PA squared is the same as BD squared, and then I can focus on triangle CBD, and I can apply pi tag on that triangle. So as a result, I should get U plus V squared plus U squared after rearranging, plus 2 times 2r, so that part is 2, the hypotenuse is 2r minus U plus V squared, right? And finally, once I rearrange this, 8r squared minus 2U times V. So last step, what is U and V? Can I represent U and V in terms of capital R and little r? Yeah, I think I can if I apply power of a point at point P and consider the line which goes through P and O here, like I assume because of the rectangular symmetry it will go through that point here, but it wouldn't matter really. So I would have the power of point P is U times V, which is our desired result, but at the same time it is equal to, because the radius of the big circle is capital R plus little r, and then this interval here is capital R minus little r. So I would get capital R plus R, and then capital R minus little r. And now that's simply r squared minus little r squared, 2 times it. So therefore, finally we get to the expression 6r squared minus plus, I should say, plus 2r squared. So what's so nice about this expression is that it is constant. It does not depend on the choice of p, if you will, or the angles in a sense, right? So it's really nice. So given the radii of the circles, then this expression here, this sum of squares, is just basically a constant, and that solves the first part of the problem. Now for the second part, so the midpoint of AB, I'll call it as somewhere probably here. Oops. Oh, sorry for that. So somewhere here, I would assume. Let's call it midpoint, so let's call it M. As B moves around, because we are pivoting around the point P, we would wonder how the location of M, the midpoint of AB, would change, right? So that's kind of the goal. But I need a couple of observations. The first observation is, because M is the midpoint of AB, it should be where the two diagonals meet. I already have the diagonal AB. As a result, if I draw the remaining diagonal, like, oops, sorry for that, like that, it would go through the point D. Okay, so we can solve this problem in two different ways. We can use synthetic geometry, or we can use coordinate geometry, actually. Well, I would just want to give you some insight about the synthetic, but I will actually do the bashing, and I will be solving this problem using coordinates. But interestingly, the key hint is, well, the key observation is that it's really the midpoint of line BC, where the radius, where the center of that circle can be, right? So this distance is equal to that distance, and this point here, which we can call it as Q, we claim Q is the center of that circle, and just of that circle which goes through M. What would be the radius of this circle, right? So basically, what is this distance between Q and M? Already my picture is pretty messy, I'm sorry for that. So if you would like to calculate this distance, actually it's not too hard to visualize it. O is the center of both circles, obviously, but if you focus on the big circle and rectangle BDEC, you would realize that O is where the two diagonals would meet, and in fact, if I draw the diagonal CD, it will go through O. I already know there are so many lines involved already, but if you draw this line and focus on the line QM on triangle PDO, PDO is a very slim obtuse triangle, but you can see that QM is actually the midline of this triangle, because Q is the midpoint of PO and M is the midpoint of PD, and as a result, QM is parallel to OD. And as a result, it should measure half the radius of the big circle. So therefore, my claim would be simply that this should be R over 2. But as I said, it's relatively hard to see this observation. So instead, I will be resorting to coordinates. And in the case of coordinates, the key observation is, again, so more or less you need to have a guess about where the center of that circle can be. Once you realize that it should be somewhere on the line OP, we can simply recast the problem in the following fashion. So if I let's pick a different color, probably black, I would say. Focus on the coordinate system, where the center of the coordinates is the point O, and you have a perpendicular here. So this is your this is the y-axis, and the x-axis, so it doesn't matter really where it goes through, to be honest. So that's the x-axis. So I'm just tilting my shape. So this is the positive x-axis, and this is the positive y-axis. So as a result, I have I claim that the center of that circle would be somewhere here and would have coordinates. Q would have coordinates that we would like to find basically. So with this new configuration, we can say the coordinates of P are, and let me actually have some space here. Sorry for that. Okay, I think that's good. So P would have coordinates, because the little circle has radius r, it would be minus r0. And then finally, ABC would have the usual coordinates, xa, ya. B would have xb, yb, and C would have xcyc. As I claimed at the beginning of the problem, interestingly, the location of the midpoint AB would be exactly the same as the location of the midpoint AC. So it will be a circle centered at the midpoint OP, but so interesting is the fact that the midpoint of BC as well will be centered at the point, this midpoint here, Q, let's say. However, it will have a smaller radius. So the midpoint of BC is on a circle, again centered at Q with a smaller radius, versus the midpoints of AB and AC can come out, will come out again at a circle centered at Q, but with a slightly larger circle. I will prove the result for the midpoint AB, but you can use the same coordinate system tools to prove it for the midpoint BC as well. So for the rest of the problem, all we need to observe is that B is on the larger circle, and as a result, so B is on the circle, big circle, and this circle, because it's on this circle, it would satisfy the following condition. First of all, which is equal to r squared. A is on the smaller circle, so A is on the small circle, and as a result, xa squared plus ya squared is equal to r squared. If you add these, you would get that xa squared plus xb squared plus ya squared plus yb squared is equal to r squared plus r squared. That's a first result. Another result can be found by noticing that BP is perpendicular to AP. All we do is we find their slopes, and their product should be equal to -1. So let's start with the slope of BP. BP is equal to, we know the coordinates of P, we know the coordinates of B, so it would be, wouldn't matter, the sign wouldn't matter, so it would be the y for the P, which is 0, so 0 minus the y for the B is yb, divided by the x's, which is minus r minus xb. And in a similar way, the slope of AP is equal to, again, I can use a similar logically, 0 minus ya minus r minus xa, and finally when I take the product, I know that the product, because these two lines are perpendicular, should be equal to -1, implying that minus yb over minus r minus xb times minus ya minus r minus xa is equal to -1. Rearranging it, so I know it's kind of a lot of Bashit thing, but ya times yb is equal to -1. We'll just change one of them, so it would be minus r plus xb, r plus xa. Finally, if I scroll down just a little bit, okay, good. I can move things on to the other side, so I would get that hold on, ya times yb plus, and then now I can expand r squared plus r times xa plus xb plus xa xb is equal to 0, and that's the second result that I found. I add condition 1 and 2. I realize that the little r square terms will cancel out, and I would have this very long expression, xa squared plus xb squared plus ya squared plus yb squared plus yb plus, remember the r square terms just cancelled, r times xa plus xb plus xa xb is equal to capital R squared. Actually this did not work as I expected. Actually, let me just make a small change here. Let's just multiply. Before we instead of directly adding the two, I will add equation 1 and 2 times equation 2. So if I take 2 times equation 2, I think that would give me the what I want. Yeah. Sorry for that. So I will still have an r square remaining on the left hand side. Let me probably edit, squeeze it back to the front, r squared, and here I would have 2 yb and 2 xb, and then there will be a constant 2 here. Yes, that should work. So sorry for this small adjustment. Yeah, so the reason I did that is because now I can nicely group some of the terms, like these terms, which would nicely give me xa plus xb squared, and similarly for these 4 terms I would get ya plus yb squared. And I still have the 2r term here, 2r times xa plus xb, and I still have the r square that we added lately, and then I still have the right hand side as r squared. Now we are almost done, because remember that how we began the question, right? So we are interested in finding the locus of the midpoints of AB, which is M. So now let's write M in coordinate. In this coordinate plane, M is has coordinates, just the average, arithmetic average of the coordinates of A and B, right? So if, let me just make a box here, the coordinates of M are simply xa, it is the midpoint of A and B, yeah. So it is simply xa plus xb over 2, and this one is ya plus yb over 2. So look at this beautiful expression here, right? So I have that, in fact, you can just call this as xm, and this one is ym. So as a result, here we have 2xm here, right? And this one is 2ym. Finally, this one is 2xm. Now, recasting this whole thing carefully, we get that 4xm squared plus 4xmr. So from these two, we multiply them, 4 xm times r, and then we have, let's put the r square first, plus r squared plus 4ym squared is equal to r squared. But then this is simply equal to, so we complete into a square here, so this is a perfect square. We would get that, actually even better, we can divide everything by 4. That would give us a better expression, I believe. So we have this plus r squared over 4 plus y sub m squared is equal to r squared over 4. And now rewriting this expression, we have that, so x sub m plus r over 2 squared plus y sub m squared is equal to r over 2 square. Now it is clear the location of the center, because M is the midpoint, but M traces all these points, so on the plane, but that would be the x component of our point here. Let me remind you of this center point here. So if you call them qx and q sub y here, so we would get that the location here for q of x here, and from this expression we just realized that q sub y is simply equal to 0. So q sub x is equal to minus r over 2, and q sub y is 0. Therefore and the radius here is obviously radius is r over 2. So therefore q, the center of this circle, would have coordinates minus r over 2, 0, with radius r over 2. And this is a really nice significant result. In a similar way, you can find that things wouldn't have changed. So going back to the picture, things wouldn't have changed if we were just focusing on the midpoint of AC. That midpoint, using the same coordinate bashing, we would get the same circle. In fact, let me go ahead and try to show you guys where those circles are located. If I can arrange the thickness, yeah, so let's make it like this, I guess. Yeah, like that. Okay, so the circle would look like this. So it would go through that midpoint here, it goes through this midpoint here. It would be a circle centered at Q with radius r over 2. Probably this doesn't look like a circle, isn't it? So something like this. But what is so interesting is the midpoint. So if I change my highlighter here, the midpoint of BC, which is probably say here, it would also trace sorry for that, it would also trace a circle, but that circle would be a smaller circle, and it would be a circle like this. So, but you can use the same coordinate bashing that we went through here in this example to show that the midpoint of AB and AC would end up being on the green circle with radius capital R over 2, versus the purple circle will, well, the midpoint of BC will end up in this purple circle with radius little r over 2. So I just leave it to you guys as an exercise. Obviously we are done, and hope to see you guys in our next video.